Okay, and then let's log in. Okay, so let's say the question was find the number that has not been used as department number in the department table. Okay, so that could be that could be a huge range, right? Any integer can be integer number, can be that. But let's restrict the numbers between the minimum and maximum integers, and then say which numbers has not been used. Okay, so we are going to create a table with, let's say T, and then just call that the DEPT number. Okay, S. Okay, parentheses. So parentheses. And then the first part, the uncle part, is just get the smallest number from the department table. Select mean DEPT number as, let's just change the name a little bit. I don't want to get the name confused. So let's just say this number, okay? No, number, N-U-M, okay, num, as num, okay. From DEPT, okay? So that will give you the smallest one. And then we are going to keep on adding 1 every time as a new number. So we're going to add a union or, then we say select num, select num plus 1 as num. Okay, from, so this time let's say from T. Okay, and then we say, well, I will make sure that the number is less than the maximum department number. So num is less than select max of the DEPT number. Okay, from DEPT. That's it, right? That's all we need. Make sense? Okay. So that these two parts. The second part is like a recursive one. So we'll just look up. So first you get the minimum department number using the first one into T, and then so you get a number. So for example, you get a 10, right? Get a 10. So the table has one column, number column, and NUM column, and it has the value 10 to begin with. And then you're going to use recursive query to query that T table. So select from T, and then say number plus 1 as new number. And then as long as this well is less than that, okay. And that's it, right? And then you write the main query. So select number from T, well, num not in. So let's say select the DEPT number from the DEPT. Something wrong? Select, hold on. What is this one? So syntax errors, partially recognized rules, real world diagrams, auto by class equals to auto. What's that? Did I miss anything here? Let me see. Oh, strange here. So I got none from T. Okay, the T is there. We are not in that. Okay, is num some kind of like a special name?
So I think for second, select num plus 1, right side parenthesis is missing.
So again, select num plus 1 as num.
Yeah, at the end, right parenthesis is missing, I guess.
Right parenthesis is missing?
Yeah.
Oh, okay, so this subquery is closed. Okay, good. Thank you. So missing right parenthesis. Okay. All right. So run that and then you should get all the numbers between the maximum and minimum. Does anybody have any other different ways to solve this problem? Does anybody have different ways to solve? So this is kind of like what we did with the year number thing, right? The year is not the year the company does not hire any employees, kind of like that. All right. Any other questions?
Can you also please explain question 6 and 7?
6 and 7. 46. And put it to here. So question 6, create a list of employee names and also their supervisor names if an employee has a manager. I think we did last week, didn't we? So that's a week before, last week. So we are going to do employee name, right? So we have to use tuple variable in this case because we have to reference the same table twice. So let's say A dot ename, and then B dot ename as manager. Okay, from employee A, let's just do inner join employee B. So how do we link? So the employees A, right? The employee's manager number is equal to B's EMP number, right? Okay. Does that make sense?
Yeah.
Supervisor name, yeah. So that's one. Okay, number 7. Is the same thing? Let me see. What is this one? Oh, well, let me see. I think let me see whether there's any difference here. So the first one is create a list of employees' names and also their supervisor names if an employee has a manager. So employee has a manager, MGR, sorry. Right? And then next question is create a list of manager names and also their supervisor names if the manager has anyone. Well, kind of similar. Let me see whether there's any difference here. So we're trying to get the managers and their supervisors. So let's use this approach first, okay? And then let's see whether we need to use a cursor to do that. So I'm going to say A.ename, select A.ename, and B.ename as supervisor. Okay. From EMPA, inner join, let's do inner join first. And then EMPB, okay, and on. So this time we want to make sure that A's employee number, A is a manager, right? So this is the manager, and supervisor, and then this is a supervisor. So A supervisor, and then B is supervising. So we want to make sure that A's employee number is equal to B's manager number. I think it's the same thing, isn't it? It's the same thing. So what if I interpret this question as get a list of manager names, and then also want to show the list of supervisors. So each one has multiple supervisors, right? So in that case, we are going to use a cursor to do it. So we'll do select. So I was just starting from main part, which is the person is a manager. Okay, so we'll say A dot B name. Okay, and A we have any other information. That's A dot hire date, A dot job. Okay, let's just do that. Okay, and then also we are going to create a cursor. And then let's just finish the cursor next. But first, as supervises. Okay, and then we're going to finish the main query first. So that will be from emp A. So we will get that, assuming that this is for managers, and then say, well, A dot job is equal to manager. Okay. So the main query will get all managers' name, hire date, job. Okay, as long as the job title is a manager. Okay, and then what we need to do is we just need to find out his or her subordinates, his supervisors, using this cursor here. Okay, so select ename, job, hire date, maybe salary. Okay, from emp. So we can also use another table variable in here instead of just using the name. So in that case, we'll have to change this b.ename, b.job, b.hire date, and the b.cell. Okay. From empb, well, then we have to make sure that for those employees we're looking for, B's manager number will be equal to A's employee number. Okay. So this could be a second way to interpret this question. So you are getting every managers and also supervisors, supervisor names only. So you don't need those job, hire date, those things. Just name, just employee name. Okay. And then for each that manager supervise. Okay, so then this will be just like creating like a table, subtable inside a table. So you have a main table which shows all the managers information, and then for each manager there's a subtable which shows his subordinate. Okay, so his subordinate employee, each subordinate is manager MGR actually. MGR is equal to the manager's employee number. I think this could be just another interpretation of this same question.
So, Professor, do we have to mention the where condition here, where A.job is equal to manager? Because I mean, as per my understanding, I considered it as a MGR column.
Okay. So you're saying that this where job equals the manager may not be necessary? It could be.
Yeah.
It could be. Assuming that as long as the employee has a the employee's manager is matching this, then this person is a manager. That could be right interpretation too.
Mm-hmm. Okay.
Yeah, I think that's right. Okay. Any other questions? So you say that sometimes same question, maybe the question is not very clear like this. You could get a different interpretation. So that's why I don't know, I email you guys or not. I just want you to put a question first and then you write your statement. So that way I don't have to go back and forth to check, say which question, for which question the statement was written. And sometimes that might be confusing. Okay, so just write a question, statement, like what I did in classes. All right, any other questions? No more?
Professor,
Yeah.
I have a question for number 13.
Number 13.
Yes.
Okay. So 13 is this one. So find 5 rundown employees from a rundown department. Okay. All right, let me see. So let's try to find the rundown department first, okay? So let's do several steps. So I'm going to select DEPT number, name, okay, location, from. So now I need to shuffle the department records by using rundown number and I create a subquery. So select star, okay, from DEPT and then order by DBMS and then the rundown other value, right? So this subquery will give you just randomized order of the department information. And then we select that, and then we say where row number is just 1, right? So less than 2. Okay, so this will give you just one rundown department, right? Does it make sense? So now we just need to find out the employees in this department. Okay, let's put this as subquery. Okay, so what I would do is, trying to find employees in this department, and then randomize also. Okay, so we do. So let's do that subquery first. Select star from EMP. Well, DEPT number in this list. Okay, in this list, and then we order by DBMS random data value. So this will give you all the employees randomized, all the employees information from that particular department, random department, right? The department that you selected is random one, and then from that, this one, just this subquery up to here, that will give you a random department. So if you say the department number is in here, then you get all the employees in that department, right? And then you auto by random, so that basically this will give you random shuffle the view, shuffle the order of your order by. There's something missing here, I think. Order. Let me check. Let's try to finish the main thing first, okay? So next, we just need to find the employees. So it may be ename or EMP number, okay? From this subquery, the whole thing, which is start from here. This is subquery here, okay? From here, okay? And then we say where row number less than how many? 6. So it's pretty, yeah, I think this is pretty involved here. So you need to just do step by step. Okay, do you have any other interpretations of this question? Rundown 5, rundown employees from a rundown department. So first of all, department must be rundown, right? Okay.
Professor?
Yeah.
Is location necessary for this one?
For this one, location is necessary. No, so you're right. So actually I made a mistake here. So say a department number in, so I should only select department number in here. Thank you, Shen. So that is right. So you should not have a department location in here. So you are looking at department number in this department number list. So if you actually put location, the department name along with that, that would be incorrect. Okay, so this subquery here just give you the rundown department number, a rundown department number only. Okay, and then you select employees from EMP table such that department number is in that instead of a rundown department number, and then you order by rundown value. So that means the employees you selected from that department, you're going to put in the rundown order, and then you select only first six. Okay, so actually this is a pretty good question. You think? Vincent, does that answer your question? Do you have a different way to solve the problem?
No, I didn't solve it, but I tried to run a statement, but I got nothing in my query.
So this one, no result. Let me see.
Yeah.
I do have 5 employees selected. So that really depends because you just select a rundown department.
Okay.
So it's just
Thank you.
Yeah, if you run again, you may have different result.
Okay.
Yeah. Okay. Any other questions? No more? All right. So if there's no more questions, we are going to move on. Just let you know that next week is Thanksgiving week. So next Wednesday, starting from 4 o'clock, all classes will be canceled. So that means this class will be canceled. We do not have next week. We do not have class. Okay. So it's kind of a strange because on Wednesday I have another class which is 2 o'clock, 2 to 3, or maybe close to 4. So that way, I think I have to cover that class, but then the classes after that will be all canceled. So then students, if the student taking that class and also the class after, then they are going to have trouble. They don't know what to do. So I'm going to email them, say whether there was any problem. So some students probably will just, do some kind of like a schedule some kind of trips. Hopefully they do not have trips this time. And if they have trips, then that will be disaster. So anyway, for this class, we will have today's class. And then after Thanksgiving, I think we'll have one more class, I believe. Let me double check. Okay, just I don't want to tell you the wrong thing here. So university background, academic calendars. So let's see. 15 weeks class, which will be the last day. So Thanksgiving break is 26th to 29th. And then for instruction day, final instruction day is December 6th. Oh, okay. Is that correct? 2020, 2021. So December 6th, that will be final day. So that means, so let's go to December calendar. So that means we are going to have class on December 2nd. That's last day class. And then December 6th will be the last day for all classes. So that means that week, the week of December 6th, will be finals week. So we do have just one class left. Okay. So unfortunately, I originally scheduled to have like 3 weeks of MongoDB. Apparently, we have only two left. So today, for MongoDB, this is the first time we are teaching it. So I don't know how the schedule will be. So I don't have any So I design this PowerPoint. I will follow the PowerPoint. Then also we do hands-on, but then we have students have a installation problem, so we don't know how fast we can go. So I would just do as we go. I cannot anticipate what is whether we can finish the entire PowerPoint or we can finish early. So I don't know that yet. So we will try. Let me see, where do I start? So I'm going to just open up the PowerPoint, and then we'll follow that for a few slides, and then we'll do hands-on. So when we get into the installation part, I will take a look at your installation problem. How many of you have installation? So I say Shane, send me emails, have installation problems, and then Pinchen has installation problem. Anybody else has installation problems?
I had one problem. Actually, after installation, we have to run Mongo command in CMD. So that is not working.
It's not working for you? Oh my God, okay. Okay, let me see. So what about others? So 3 people have that problem. What else? Any other people has a problem? Okay, so we'll get into the installation issue, and then since this is a small class, actually we can take care of each of you individually. So that's this type of sessions or classes are better to be on site, so that you bring your laptop, and then I can fix it much easier than just doing this online fixing. So we'll see. We'll see. So we'll just do some concepts first, and then we'll get into installation part. I will go through some installation steps, and I see whether you have any problems step by step maybe, and then we'll do hands-on. We are not going to do very complicated queries today. Just let you know that the query, this MongoDB can be, MongoDB is more like a JavaScript interpret online interactive interpreter. So in other words, you're basically just learning how to write JavaScript, how to code JavaScript. Okay, so it can be for some jobs can get complicated, but we will just do step by step. It's actually pretty fun to learn, I think. Okay. Last week I sent you an email telling. Did I tell you? Did I send you an email about this, about SQL? So actually, if you're going to job search, in the job market, SQL and JavaScript are two JavaScript coding programming are two top skills that the job market is looking. So there's a lot of demand for people with these skills. Okay. So as a matter of fact, if you can do JavaScript well, you can just go to Google, Facebook, command a very high salary. So I know that there's young kids, just like a fresh undergraduate student, get out of college, just graduated this year. They command the salary like a 200,000 or something like that, above. So this is very crazy for in this IT market, So anyway, so MongoDB, you might want to use that opportunity to just get a little bit knowledge about JavaScript also, okay? Because of the main reason, the main point of this, of course, is not learning JavaScript, but is learning different kind of database with different kind of data model. Okay, so let me open up the PowerPoint, and then let me put that screen to this one. Okay, so we'll go through just get basic concepts. Okay, so what kind of data model is it, and what are the advantages of NoSQL database, and then how MongoDB handles basic data operations. Okay, how to, for example, to log on, how to create new databases, how to create a new We will have some different terminologies too. So we in the relational model we talk about tables, take rows, columns, all that. But in MongoDB we don't. Okay, we're using different concepts. Okay, so we'll get used to those concepts for this new model, for new kind of database. Just let you know that MongoDB in Wall Street is considered future of Oracle. You know, Oracle was successful in 1980s, 90s, right? And MongoDB is considered the future of Oracle, but Oracle is not the future of Oracle. Okay, so this MongoDB is open source database. However, you know that the company is running that is actually get a very high market value, just because of people anticipate that this is going to be a future of database. Okay, so let me start running this script, this PowerPoint, and let's see whether you have any questions along the way. Do you see my PowerPoint? I think I was sharing this screen here, right? This is the one. So yes, you see my mouse in the field, right? Okay, that's good. So I have several screens, and then sometimes get confused which one I was using. So no SQL database. So in particular, we focus on MongoDB, and also we will give you some other examples of no SQL database. So the first question is, what is a no SQL database? No SQL database, just essentially a non-relational database. So I don't think the name is kind of confusing. It's really not just a no SQL. It's not relational. That is the nature of the no SQL database. Okay. So you know that in the relational database, we're using tables, right? And then tables are connected through primary keys and the foreign keys, right? But no SQL database does not use that. No SQL database using totally different data models. Okay, so there are actually quite a few no SQL database of choices out there, and they are using different data models. I'll give you 3 examples here. The first example, the data model is so-called document model. So in this kind of database, you're not talking about the records. Instead, you talk about a document. And then instead of talking primary key, foreign key links, you actually you can embed documents inside documents. So, for example, if a department has multiple employees, you just don't create two different So let me give you the terminology again here. Okay, so in this model, we are talking about documents. Documents just like just records. Okay, just like records. And then table, we're not using table, we're using so-called collections, okay? So documents and the collection, documents is inside the collections, all right? So instead of primary key, foreign key, you actually can put a document inside a document, okay? So if one department has multiple employees, you can actually put those employee documents inside the department documents. Does it make sense? So that is how the document model is using. So instead of familiar rows, columns, you are using each So actually we will be talking about the so-called JavaScript object notation. That is just like how do we organize your document. Okay, I'll give you an example on that. So at this point, just understand that. So we're not talking about rows. Instead, we're talking about documents. Okay, and the columns, well, we still have fields. Okay, we still have fields and have like a key value pairs, and the column is just more like a key here. Okay, in the document model. Okay, and then each document is structured using JSON symbol, JSON notation, JSON format. Okay, and I will show you that. And this document model is so basically each document is considered like object, okay? And then so some students took 643 and learned the concept of objects. And so objects, you see the object has data, right? Has like a bunch of attributes and also have functions to process those documents. So basically this JSON is actually format for storing object data in JavaScript and in some other programming languages too. Okay, so this is the first data model. So I'll show you an example, and then it will be clear. And then there's a graph model. So in graph model, you basically just use the node and the edges, node and edges to link different nodes. Okay, so using graph model, you require all data to reside on one machine, and which generate one of the key advantages. This class of database uses structures like data nodes. Okay, data nodes and edges and the properties, making it easier for model relationship between entities. So you just think about that each node. It's kind of like so you're talking about data node and data edges. Okay, so that's how this graph model is. And then the last one is a pretty simple one, just key value pair. So basically, you have a list of keys and the values. For example, you can say, age value 29, name value is John Doe. Okay, address is some kind of value. So it's just the entire database is organized like key values. Okay, pair of key values. So this is pretty very. I think it's a simplistic model, very simple model. Okay. So well, simplicity is scalable, but the simplicity and the scalability comes at the cost of query complexity. So we're not going to look at this data model, so we will not get into details of this. Okay? So this first model is the one we are primarily studying in this class. Okay. So you have a question about why no SQL database. This is actually a very big question. So why relational database does not work, and why we need this no SQL database? To me, the two most important reasons. The first one is we have so many inexpensive storage and processing power, especially cell phones, right? Everybody has cell phone. This is just just almost distributed in the entire world. Okay, everybody hold like a like a data nodes. Okay, and you process data, you generate data all the time using your cell phone, right? So then the question is, this data, where do you put that data? So if you want to put that data, those kind of data into database, then you realize that the database has to, first of all, whether database structure will be able to accommodate all that. Okay, so if you have a certain number of columns, then those columns are fixed, and you cannot add a new kinds of data into it. So that will be restricted, right? So that is one restriction with relational database. Relational database has been traditionally used for transaction database, for very formal business database. So we design that, the structure is fixed. And if we need just, with even new kinds of data, then we have to change the data structure. We have to add new columns, right? So that would be very time consuming to do that, okay? So that relational database have that kind of expense. Secondly, we, because of this low expensive storage like cell phones available worldwide, and then we are talking about apps. Those apps are actually a distributed system. Okay, it's global distributed, and those those apps can't just think of that. So it's not a traditional just client server system that it's just have one single point for data processing. But here we actually, every app is processing data, so it's more distributed. So that basically create a demand for high availability and also speed. So you really need the data is always available, and also you have to have high speed of data. So if all the applications are going to get data from the central database, and then that database is going to probably, a lot of databases are going to crash. Okay, so that is another reason for no SQL database. Okay. So primarily two reasons: distributed and also low expensive storage and processing power everywhere. So that those two things create the demand that we have a big data, and then we have the data which is we cannot rely on fixed structure to hold this data, and we hope that the database is always scalable. Here, scalable is not database, of course, relational database is scalable. You can always add more rows, more records to it, right? So it's basically it's a vertical scalable. However, it's not horizontally scalable. So in other words, you cannot just arbitrarily create a new fields, new columns to existing table, right? So horizontally is not that scalable. And also performance-wise, because we have higher requirement on data consistency. So and also no duplication, and then it will come with like a cost of performance. So those are primary reasons for for the rise of a NoSQL database. Okay. NoSQL database non-relational, and they are tableless. Okay, so what does it mean? It means well, you do have something like a table, but it's not like a table. There's no schema. I think this should be called schemaless, not tableless. Okay, so scalable horizontally, so vertically with relational database. I just explained that. So they operate without a schema, freely adding fields to the database without having to define the changes in the structure first. So in other words, you don't have to use alter table, add these columns or change those columns before you change the data, before you add the data. Okay. So maybe in one case, we add somebody just add a new piece of the information about a student, which has student ID, student name, and then the second student will just come along and add his student ID and also just a bunch of addresses. Okay, so the first one does not have addresses. So now, if you are in a relational database, you have to, what you have to do, you have to go to database and try to make sure that you can add more you can add address field. Probably just make that as a weak entity so that the students can add more addresses, right? And that has to be done by database administrator, but cannot be done by user, right? So that that scalability is restricted. So non-SQL can overcome that problem. Okay, and also non-SQL database are typically optimized for one specific data models. So for example, the document model or key value pair. Okay, so that can enable higher performance than trying to accomplish similar functionality in relational database. So it can achieve, because it's restricted to the simple data model, and then the performance can be improved. Okay. Okay, and there's no SQL database also just because of a performance requirement to achieve the high performance. Sometimes SQL has to sacrifice something else, okay, like availability, like consistency, all that. So SQL database generally follow a balanced approach. So what is the balanced approach? First of all, availability. So you should make it basically available. The database should be available most of the time. So that means it's not 100% of the time, just most of the time it's available. Okay, so if you have an app trying to get a data downloaded, and then maybe most of the time it's available, the user is satisfied, but occasionally you have a problem, then it's not a big deal, right? It's not just like you're running your database for Amazon. So if it's not available, you're causing like millions and millions of dollars for your seconds, right? So that would be problematic. But that basic availability should be reasonable. Secondly, for consistency, so we always, for relational database, we also have to make sure that same piece of data for same entity must have same piece of data everywhere, right? And also all the constraints must be satisfied, okay? But for non-SQL, so we talk about soft state, it's just temporary inconsistency should be okay. So if you have an inconsistent temporarily, it's not a big deal, okay? So that's called a soft state. But eventually, we just need to make sure data is consistent. So system will come to the consistent state after a certain period. So maybe once a day, once a week, make sure that all data, just for each entity, all data are synchronized, all the constraints are sacrificed. All constraints are satisfied and not sacrificed. Okay, so those are just like a trade-off for performance. Okay. Let's talk about a few examples of NoSQL database. So NoSQL database are usually open source. And so really it does not cost much. So for example, MongoDB, you download it and it's pretty much free, right? Unless you want to get some kind of a special or privileged tool to manage your database. Otherwise, you don't need to pay a penny. Okay. And NoSQL database can be a appealing solution for smaller organizations. Okay, especially if you're trying to create like app and want the app to be available for other users. You may not be able to afford or to pay to Oracle to get like a database installed, but you can just use MongoDB. Okay. So these are the most popular choices of MongoDB. The NoSQL databases. MongoDB is one. Okay, I consider it's one, probably top one. And Amazon has DynamoDB also. Okay, there's something called a Couchbase and the Redis. Okay, and I have a few more examples, and then let me show you those which one using which model. I think I know that this one is using document. Amazon is also using key value pairs. And this one is using documents. I'm not sure. Let me check. Okay, so here, DynamoDB is using key value pair. Okay, just using simple list of keys and the values. Okay, and then there's a big table HBase, not very familiar with, and they are using column store as data model. And then MongoDB, CouchDB using document stores. Okay, so that's the one we are going to learn here. And the GraphDB, there's a sample example is Neo4j. That one is using Graph database, Graph model. Okay. All right, and let's talk about in general some kind of general theory about so-called distributed systems. Okay, so there's something called a CAP theorem, and there's something called ACID properties. So let's talk about CAP theory. So we basically ideally any distributed system should satisfy the three properties. Consistency, that means that every read will fetch the last write, right? Does it make sense? Okay, so the data should be so focused. So you just create a new, for example, you just create a new reservation, and then you query whether the flight has been resolved or not. Then the last reservation should be affected. So you should have your result, your query the result to say whether the flight has a capacity or not, and then the last so the query should reflect that the last reservation. Okay, and then availability is of course is very important property. Okay, so you should make sure that reads and writes always succeed. Okay, always available. In other words, each non-failing node will return a response in a reasonable amount of time. So that's availability. Okay, and the third property is tolerance. So tolerance is actually error tolerance. So implies that system will continue to function even though when there is a data loss or system failure. Okay, so among the three properties, consistency, availability, and tolerance, what a CAP theorem basically saying that any distributed system can only satisfy two of the three properties. Okay, so that means you cannot really, no distributed system can do all three, can have all three properties, can satisfy all three properties. Okay, so let me give you examples of how are they certified. So for example, for MongoDB, where's MongoDB? MongoDB is here. So MongoDB is certifying consistency and tolerance, but does not certify availability. Okay, and then on the other hand, relational database is emphasizing availability and the consistency here. And what is this one? CouchDB. CouchDB is emphasizing availability and tolerance, partition tolerance. Okay, so let's just give you an example how this sample non-SQL database is certifying this CAP theorem. Okay. Now let's talk about ACID properties, and some of the properties we already talked about in the relational model. So like atomicity one, atomicity one and the consistency one. We already know that. So you know that each database transaction typically consists of multiple SQL statements. Okay. So what is atomicity requires that all these statements must be run all together completely or none of them at all. So they must be run as a single unit. Okay. Either they succeed completely or they don't succeed at all. So that is so-called atomicity property. Okay. Consistency is also something we're familiar with. That is, we just make sure that all the data, you write to database must be valid, okay, according to all the rules, constraints, cascades, triggers, all that, okay. So make sure that so that just ensure that database data are consistent, okay. And then we have this probably is something new to distributional database. So in my database class, I did not cover that. One is called isolation. So this is just ensure that if you have a multiple execution simultaneously, and the database should ensure that this concurrent execution of transactions leave the database in the same state as they would be obtained if the transactions were executed sequentially. So in other words, if you do several users are doing all the transactions simultaneously, and the result should be same as if you order these transactions in a sequential order. So just ask these users to do transactions one by one. Okay, so that is so-called isolation. Does that make sense? Okay, and then the final one also has something to do with the distributed database, that is durabilities, and that guarantees that once a transaction has been committed, and it will remain committed even though system fails, like a power failure or that. So as long as transaction is saved, committed, then that it should be saved. Okay, does not matter the power failure after that happens or not. So that durability, that's so-called durability properties. Okay, so those are the properties that are desirable for distributed systems. Okay. All right, now let's come to MongoDB. So first, MongoDB use document-based. So document-based, each document is also called object. So sometimes called object-based, object-oriented model, or document-based model. Okay, same thing. So each record equals to document is also equal to object. So just imagine that now you have to change the terminologies. Here, each row is record, right? And that's all. Now we call that as document. And it's also called object. Okay, and the record is represented as document. A document is a combination of field and value pairs. So now here is a document. That's one. So each document is surrounded is enclosed by this curly brackets. You see that? Okay, and that's basically, so inside these curly brackets, you're going to have a list of key value pairs. So name, age, value, and then this is another key, not the key. But then for this key you have two values. So that's basically the groups. You have two groups, right? So that's a list. Okay, so you're going to use this square bracket shows that this field. This column has multi values. So this is the multi value for this field. Okay. So normal forms, first normal form is no longer required. You see that? So in relational database, we require that each field has only single value, right? But not anymore. Not anymore with MongoDB. Okay. So if one have multiple values, then you can just do, just use square bracket. One value, comma, second value, okay? And now again, you'll notice that inside this document, key value pairs, each of the key value pairs key value pairs separated by this comma here, and then key, and then colon, and then value. Regarding the value keys generally, if key has just single name, just single noun, you don't have to put a single double quotes around it. But there's no harm to put double quotes around this. So instead of this name, you can also put double quotes around this name. Same thing with age, double quotes, groups, double quotes, quotes. Okay, so that's okay. That is not a problem. But then for values, we have a couple of, I will talk about data types here. So this example shows that we have two kinds of data. One is text. So this is a string. This is a string. So when you have a text, you put double quotes, okay, around it. So remember in Oracle, we use single quote, right? But here we use double quotes, okay? So JavaScript is coming kind of like it really does not have anything to do with Java, but it's, in syntax-wise, it's pretty similar. So since JavaScript, Java, C, C++, so for text, you use double quotes around it, okay? C# also. And then if you have a number, just use number alone. Don't put single quote or double quotes around it. Okay, and this again, this text, right? So you put double quotes around the text values. Okay, and then we'll be talking about how to do data values, how to do object ID values, some other different kind of values. Just in a few more slides. Okay, so this is important. Just remember that this is how MongoDB is organizing your document. Each document will be just created like this, just curly brackets, and then each document is going to have a bunch of key value tails. And those values, simple values, you just put a single double quotes around it for text, or just single value there. Okay, or sometimes these values can be complicated. The values can be object, can be document themselves. Okay, so you can actually put documents inside the documents. Okay, these documents can be also like multiple documents. So then you have to use this list or array to hold that. Okay, your square bracket to surround that. Okay, is that clear? And then let's talk about the JavaScript JSON, JavaScript object notation. So this is JSON is an open standard data storage format. Okay, and you can tell from the previous example is human readable text, right? Can you read it? So for example, like this, you understand that what it's about, right? So this is about somebody, okay? Somebody who has name, has age, and also has those groups, join those groups, right? So this format is, has all the advantage that is human readable, okay? And then so this JSON is primarily used for data storage and also data interchange among programs. So for example, I write a JavaScript on one website, and then I need to communicate with another JavaScript inside the same website or different website, then I will use the JSON to communicate the data. Okay. Just let you know that there are two kinds of format, that data format are widely used for program interchange, for data interchange among programs. And JSON is one for JavaScript, and then there's another one called XML. Originally, I scheduled to design to have a class talk about XML, but apparently we do not have time to do that. So XML is also data format, storage format, and it's also very flexible for data interchange. That is typically interchange between APIs, application programming interface. Okay, so for example, if I write a program on one computer, I need to communicate my data with another website or maybe another computer somewhere else. So I will use XML to communicate data. Okay, so for example, if I want to open up some kind of small store, online store, and I want to use Amazon's catalog, so I will just write a query. So if somebody searches for product, my application does not have to have all data about all the products. So I can just search Amazon to get the data and then display it inside of my program. So in that case, I will ask Amazon to communicate the data as XML to me, and then I will display the XML result using inside of my program. Okay, so again, so that will be XML, so XML data format, but this is JSON format. Okay, JSON is really mostly for JavaScript. Okay. Each object consists of a list of attribute key value pairs. We already say that, right? So each document has, those type of things. And then JSON is a native data format to store and transmit data by many programming languages such as JavaScript. Okay, here there's another. I was trying to tell you there's another advantage with the JSON here. So instead of using joins, instead of using primary key, foreign key links, how do you link those data? How do you link documents? This is how you link documents here. Suppose I have a person, okay, a person. They have address, right? So instead of creating two separate collections, one for this person's name and some fields, and then another one for addresses, and then trying to link them using some way. This is way, this is a simple way to just embed addresses object inside this person's object. So here we see that this name, this person John, has two addresses. So you just, the square bracket just means that you have multi values, right? And so what are the values? You have two values. Each value is actually another object. So each one is address object. See that? So curly brackets for one object is address and the status, and one address and the status. So you can just imagine that this could be more extended to more field, more value, more key value pairs. So you have street address, city, state, zip code. You can have a list of those, right? And that will be considered as one single, separate document. It's just one document embedded inside a person's object, person's document. Does it make sense? Okay, so you see that embedded documents, embedded objects. So we use names interchangeably. Sometimes they're called objects, sometimes they're called documents. So anyway, so objects, documents, and the records are pretty much, same thing. Okay. And then MongoDB organizes the same kind of documents into a collection. Okay, that is kind of like a relational database, right? So for example, all employees put into one table. So here, all employees you put into one collection. Employee documents put in one collection. And all those documents you put into another collection. Okay, and as far as how you're going to model the relationship between, for example, customers and orders, there's a one-to-many, many-to-many, all that. I put like review, put like a rating list, a rating that's copied from MongoDB directly. So how to model this one-to-many, one-to-one, many-to-many, those type of things. Okay, so this, they give you examples very quickly. So basically, generally, if you have one-to-one, you can make just one document, combining all this list or all the documents into one, just like one document. But if there's too much, then you can split. Put into put like some kind of like a main list, main attributes into one document, one collection, and then some details into different documents. Okay, and if you have one-to-many, so you will just create one collection that shows one side as a main document, and then the many side as like embedded documents. Okay. However, if that if each one has too many of the sub documents, then you also going to split. So what you're going to split is that you're going to put some embedded documents into the original, the big document that contains the sub ones. Let me just talk about say department and employees. Okay, let's say each department has many employees, right? So you can just create one collection called department, and then with employees as embedded document. Let me just go back to the previous slide. Okay, like this one. Okay, so you have one collection for all departments. Okay, department name, department location, and then you're going to have employees. So employees, you're going to have a list here, right? And many employees, employee 1, employee 2. So for employees, it's probably okay, you can do that. But for some cases, that if you have too many of these employees, okay, too many of these embedded documents, what you would do is that you will just put a few significant ones, or maybe most recent ones, into this main document, and then for others, just put into separate location, separate collection. Okay, so you see that is pretty. There's no really scientific, no fixed rule to follow. Is really so most important. So most important thing here is trying to make sure that your data is always available, partially partially available, and also it has high performance. That is the main issue, main criteria. So you can just imagine that when people are looking for each department, then they see a couple of employees, right? And then they can click on details, and then they get more employees loaded. So then they go to another location to find all employees. You see that? So you have some sample employees in here, but also some more employees in separate place. Okay, so that's how you can handle one-to-many relationship. Okay, so that document basically give you examples on how to handle all these kind of relationships. Okay. All right, so now let's see. Okay, so now MongoDB organized same kind of using collection, just like a table. Okay, yeah, the collection is a schema list. Okay, we already talked about that. So this is an example here. So documents in collection can have different fields. Okay, so for example, this is a person document. The person has a name and has an age. But then you try to add another person. This person all of a sudden add a social security number, a name, and also put groups in here. And those fields do not exist in here. So when you first time insert this collection will be created just having two fields. But then all of a sudden there's a next user trying to insert this one into the same collection. And then your database has to be horizontally scalable to be able to add the new fields. The fields, the schema is more, the structure is pretty fluid. Okay, pretty fluid. It's not fixed. So you do not have to ask a database administrator say, you do not have social security number field, and you do not have groups field, so that you have to add those fields. So use an alter table, blah blah blah, and add these two fields, and then before I can add those data into it, and that is not acceptable to NoSQL. Okay. So MongoDB provides flexibility in dealing with schemas. Okay. And then JSON, and then we'll talk about a binary JSON. So what is binary? The JSON is encoded as a binary data, so it's called as a binary JSON. Okay. So that may not make big sense to you because all data in the database in the computer is going to be coded as binary. But however, the Bison added a couple of more extensions to JSON. JSON does not have that. Okay, so one of that is you're going to have like ID field. This ID is actually data type is called object ID, and this object ID is very, very interesting. Okay, so it's this is object ID. This one. Okay, so if you want to add create a value key value pairs for ID, then this is how it looks like. So ID, I said you can put double quotes around it, or you can just don't have to put double quotes for the key value for the key name. Okay, these double quotes are not necessary. And then the value for the object ID is something like that. So say object ID. So just capital O and the capital I, the small letter D. You see that? So you have to spell that exactly like that. And then you put double quotes, and then actual ID will be in here. Okay, double ID will be inside double quotes. Okay, so what is this ID? Usually the object ID will be generated by MongoDB automatically, and so the object ID will look like this. But this object ID actually consists of 12 bytes, 12 bytes of data. Okay, and what are 12 bytes of data? First 4 bytes. So basically, if you're looking at eight numbers in here. First 8 numbers will tell you the timestamp. So when you create a document, the time you inserted the record, you create the record will have timestamp here. The timestamp, the first 4 bytes will show the timestamp. Okay, and then second 5 fields, the 10 numbers after that. This is called hexadecimal number, 16-base number. Okay. Hexadecimal number. So each 2 numbers representing just like each 2 numbers representing 1 byte. Each 2 numbers here. Okay. So hexadecimal numbers use 0, 1, 2, 3 all the way to 9, and then after 9, you're going to use A, B, C, D, E, F. Okay. So in total you have 15 numbers. Okay. And then after 15, then you're going to just just go to the next the one to the next layer, the higher layer, to be 1, and then starting from 0 again. So in other words, 1 0 will be representing 16, and 1 1 representing 17, like that. Okay, so if you start counting that hexadecimal number, you will just do 1, 2, 3, 4, 1, and all the way to F, right? And after the F, then you start from 1 0 and 1 1 1 2 1 3 1 and 1 F, and then after 1 F, you're gonna get 2 0, starting again 2 0 2 1 2 2 2 3, like that, and then go to 2 F, and after that you get to 3 0 3 F. Okay, so anyway. If you count any 5 numbers after the first 6 numbers, that would be some kind of round-down number, okay, it's generated. And the last 3 bytes will be just like a sequence number. So that's how this object ID is generated by MongoDB. So if this number is generated by MongoDB, we can actually get a timestamp. For each object, for each document that was created. Okay, does it make sense? Okay, and let's talk about the date. Okay, BSON actually extends JSON model to provide a data time type. Okay, so JSON does not have data time type, and then BSON does. So BSON include this object ID field, which is not in regular JSON. And the BSON provides that. So the data time is another type. Okay. So how do you create data time values? So remember in Oracle, we put data values like what? Single quote, right? 2 digits for day, and then 3 letters for month name, and then dash, and then 4 digits for year number, right? So that's default date format, right? Or if you have some other arbitrary format, like a January 1st, 1996, something like that, then you have to use toDate function to convert that into Oracle date, right? So how does Mongo handle this date? So basically you have 2 ways to handle date, 2 ways. The first approach is you can use a function called isODate, so that you can just imagine that is just like a toDate function, okay? isODate, okay, is object date, okay? So here, for example, I have one document for student ID like that, student name like that, and then the student birth date. So the student birth date, you are going to put that inside, it's supposed to be double quotes here, okay? And then say 2001-12 and then -31, and then this is time zone, okay? Time zone. So yeah, so basically you start with this time, T representing time, and then you say 12 o'clock, 01 minute, 15 seconds. And then this is 1, 2, 3. This is like a millisecond, okay? Millisecond. The Z representing this Greenwich time, so Greenwich Standard Time, okay? So if you have this kind of time, so remember that date is so basically same as date, right? Actually it has time also, just like Oracle data time. Oracle date, it also has time, okay? So you get just one point in time. So inside the computer, the data time in JavaScript, okay, is represented as a number of milliseconds starting from 1970, January 1st, 1970. So starting from that, so total number of milliseconds, so it's just a total number of, just like an integer, okay? But then that number is representing data time. So basically, to enter some kind of data time that we are familiar with, then this is how you do it. So you can put like a general format and then put double quotes around it. So you don't have to have time. You can just have like a date, year, month, date, and then double quotes around it, and then say isODate. Okay, so that will convert the text into date. Make sense? So this is how we handle data in MongoDB, handle data values. And the second approach is just using this so-called constructor. I'm going to show you examples, so how to declare variables in JavaScript. And this is actually how to declare date. And this date is actually called a constructor. And this constructor will be construct new data values based on the year number, year, month, day, hour, and the minute. Okay, so you can just use this constructor to create a new data value. Okay, so there's will be 2 different ways to enter date values. So this is So students taking database object-oriented programming class, you already know that this is, a 36043 class, okay? You already know that this idea that this is new and then constructor, right? And this will create a new object, right? So basically this create a new date time object. Does it make sense? Okay, so here these are two students documents, and then each document consists of key value, key value, key value. So last one does not have comma, and all others have comma, separate each key value pairs. Okay. All right, and let me see if I, what time is it? I don't have a clock here. Alexa, what time is it?
The time is 8:06 p.m.
8:06, okay, so we'll just do a few more slides and then we'll take a break, okay? And the next slide, oh, okay, so this are general MongoDB data types, string, we already know that, right? String, and then integers, can be 12 or it can be 32 or 64-bit integers. And then double is just like storing like decimal numbers, like salary, those decimal numbers. So basically, these two will be just numbers, okay? Numbers. And then array, just like a list, if you have multi-values, then you just list, you use array, right? So you use a square bracket, separate a list create a list of values. Okay, so that that is really not a data type for relational database. Relational database does not allow you to have multi-values. Here you can. And then you have timestamp. Timestamp is a separate data type, and here it says 64-bit. 64-bit. So you say, so what does it mean here? So previously, let me say this object ID. So in object ID, I said first 4-bit is timestamp, but here it says 64-bit. So a little bit inconsistency here. So that inconsistency is not strange here. It's just because for typical timestamp, okay, you have 64-bit, but the most essential ones are only 32-bit. The first 32-bit, 4 bytes are essential ones. So this object ID, which contains the stamp ID, the timestamp, and that is have only 4 bytes, right? So this 8 bytes. Each byte is 8 bits, right? So this 64-bit is 8 bytes, right? So regular timestamp is 8 bytes, but only 4 bytes are essential. The other 4 bytes not essential. Okay, and then date is a 64-bit integer that represents the number of milliseconds since the Unix epoch, January 1st, 1970. So after that, the midnight of that, every millisecond will be considered like an integer. Starting from that is integer. So if you have like a, 10 million whatever number, that number is representing a time after this. Number of milliseconds after this time, after this date. Okay, and the object ID, we already talked about that, and basically have 3 parts. Okay, timestamp, random number 5 bytes, and also 3 bytes for sequence number. And then if you're going to store data for like some kind of like a image, music, or video, or that, so you're going to store binary data. So there's a binary data type. Okay, so there's a null value here. So I will talk about this one. Just we'll talk about a grid, so-called grid FS. So how do you load it's like music or picture files into MongoDB? Okay. All right. Let's see. I tried to. I don't know how many slides. Let me just run a few more slides. Okay. So MongoDB query language. So this I just talked about. We are going to talk about the query just more this week and second part of class and also next week. Okay, but just give you some kind of like a perception knowledge about the query language. Okay, the query language support basically you can create, read, update, delete. So basically, the SQL statement. Remember, we do update, delete, so that every MongoDB can do all that. Okay, and also you can do data aggregation using group by. Okay, you can also do text search. Okay, so that kind of like Oracle we have been using, right? We have learned all that in Oracle. And then suppose, okay, let's just give you some kind of flavor of how the query would look like. So it's not SQL, okay? This is how you do query. Suppose we have a collection called employees, okay, or table. Just imagine, okay, as follows. And then you want to find all employees documents inside the collection, and this is how you do it. So you say DB, that's keyword, it only change, and then the name of collection, and then you say dot find, okay, and inside parentheses, inside parentheses you can specify criteria, okay, and then if you want order, then you say dot sort, okay. So we'll see there's some examples today. Okay, so the result will show you something like this. So there's 2 documents here. Each one has ID, and this ID probably will be just created by the user. Okay, it's not created by MongoDB. MongoDB will create like a 12 bytes. Okay, long ID. Okay, so you can create your own. So if that is the case, then you just say, key. This is the key, and then value. You say object ID. Remember, capital O, capital I, small d, okay, and then parentheses, and then double quotes, and say 1001, and double quotes, so on that, then that value can be inserted as object ID, okay? And then name, unit, you say that those are the standard text fields, right? So when you do query, you find, then you basically get, the collection, all the documents inside the collection like that. Okay, if they have different fields, it will show up as different fields. Okay, so this one just happened to have the same fields for two different documents. Okay, so here MongoDB provide also aggregate framework to perform aggregations like operation group by thing. Okay, aggregation framework can group data from multiple documents and perform variety of operations on the group data. MongoDB provides aggregation pipelines and then map reduce functions and single purpose aggregations. So we'll get into that maybe next week. Okay. Now, how does MongoDB handle something that is beyond the limit? So for example, one limit is that maximum document size 16 megabyte actually, 16 megabytes. So each document size is restricted to 16 megabyte. So then how do you handle the case that you have, the document has large, say one document has like one large file, like a MP3 video, audio, or maybe like a picture, which can be very likely beyond this maximum limit. Right? So how does MongoDB handle that? MongoDB is using something called a grade FS, grade file system, to divide the file into parts called chunks. Okay. And I'm going to show you that there are, so basically you're going to have 2 places, two collections to store. The first collection just show the main file attributes, file document, and then the chunks, they will show every chunk, every part of that file, that you divided into in the second part. Okay, so each part will be no more than 255. So first field will be 255 exact, but last one may not be, okay? Last one will be whatever left over from the division. Okay, and then what about you have a database server, loss of a database server. So we're talking about distributed systems. So if one server is down, then all of a sudden some users will complain, they cannot access data, but that's not a concern because MongoDB have a mechanism called replication. And the replication allow you to just replicate one instance of database to different database servers to provide the redundancy. Okay. And then we talk about large data or big data, and then typically we have CPU and IO capacity limit, okay, IO limit. So input output, you can only have a certain amount of data per second to be read or write, okay? So how do you handle that limit? And MongoDB uses something called sharding as a method to distribute data across multiple systems, okay? So I'm not sure whether the book has some chapters talking about this, but we do not have time to cover this last 2. But for this grade FS, I will have just 2 slides summarized to you how we handle large files, okay? So grade FS is for storing and retrieving large files like images, audio files, video files. It is kind of file system to store files, but its data is stored within MongoDB collections. Okay, so basically you are putting data inside MongoDB. Okay, it's not a good practice. You know, typically, if you have a lot of large files, you do not want to put files inside the database. You do not want to make a database to be like a file system. Okay, however, MongoDB allows you to do it. So even though it's not the best practice. Okay, so what's the best practice is that you just create document which has a file name link reference to a file which is outside of MongoDB. That is a best practice. Okay, so MongoDB has a capacity to store files. Okay, already said that 16 each document has to be like no more than 16 megabyte. Okay, so DBS file that's GridFS will divide the file into chunks and store each chunk to separate the document. Okay, so one file you may create like one document inside a file system. So you're going to have two collections. Okay, one collection is called fs.files, another collection is fs.chunks. Okay, so if you have like a large file, you will have one document in here, which will just store the file name, file location and stuff, file name stuff, okay? Basically file object ID stuff. And then that file will be split into multiple chunks, and those chunks information will be put inside this document. So you have multiple documents put in here, okay? Put inside this collection. So these are two collections, two tables, okay? Just imagine these two tables. One table have just information about the file itself, and then this table will have multiple documents for different chunks. Does it make sense? And each chunk is identified by unique object ID field, and the file fs serves the parent document, and the file ID will be used as a foreign key inside of here. Foreign key. So how do you know those chunks? How do you know those chunks belong to one file? Well, those file ID in here will be like a foreign key in here, like a reference. Okay. So we are not talking about the concept of primary key, foreign key here, but this will be called a reference. Okay, so reference. So this reference field will be referring to the parent document. Okay, here is an example. Okay, suppose I want to add a file like a song.mp3, this big file, to GridFS. So what you would do is that you're going to use this file, so mongo files.exe. To load the file, to put this file into MongoDB, and then automatically after that, MongoDB is going to create one document inside the fs.files collection. So if you do find, and this will be the result. Okay, to find the find the file you just created the document that because you upload this document, this MP3. Then the parent document will be this one. So you should query that, and then you get that. The file name is that, chunk size that, and then object ID is that, okay? And then upload date or that, okay? So this is date, right? This is the number of milliseconds. This is the number of milliseconds, okay? It's not using the format I was talking about, just like 12, comma, 1991, 12, 1, something like that. But this is another way to just put the number of milliseconds starting from January 1st, 1970. So that will give you the exact time for the one point in time. And the MD4, that's just like just checking the format. Check just like a inquiry. So when you do so it's like a check and error. So make sure when you upload the file, the file has to, do the MD file collection computation. Make sure that there's no error during the communication, during the transformation, during the uploading. Okay. And then if you go to another document or another collection, go to fs.chunks, then you're going to find all the chunks with this same object ID, file ID. The file ID is a reference inside the files.chunks, right? And then use this document ID, okay? This object ID. Use that, find this object ID. So then that will give you all the chunks belong to this file. Okay. I think we can take a break now. We will hopefully we can finish this whole thing. So we'll talk about installation next. Okay. Let's just have one more slide and then talk about installation. Yeah. So let's do one more slide. As well. So there's terminologies here. Terminology. What equivalence here? Okay, so we in relational database, we talk about database, and then MongoDB we also talk about database. Table map to collection, right? We don't talk about table, we talk about collection. And record, same as document or object, okay? Columns, so in that in a relational database here, we talk about fields, okay? Kind of similar, right? Fields or key value pairs. So actually it's a key value. Key value is actually, yeah, well, yeah, it kind of like that. So basically each document has a key and each document consists of a list of key value pairs. Okay. And ACID transactions, we same as the ACID transaction here. Index, okay. Joins, instead of using equal join, explicit inner join, in left join, right join, then we are talking about embedded documents here. Okay. Or we can use this to look up. Group by aggregated pipeline. Okay. So those are just terminology equivalents between relational database and MongoDB. Now let's take a break. Okay. So let me stop coding for a second. 0. Okay. So now you share your screen with me. I will tell you what to do. Okay.
Okay. Is it sharing with you, Professor?
Let me check. I don't use blank. I don't say anything.
All right.
It's blank.
Not sure why it's. I don't know.
Okay, so let's say you exit and then you say who, Mariana, you say you have problems, you have same problem?
No, I think it's me. It's Ping Chen.
Oh, Pinchen, okay, so Pinchen, you share your screen and then let me, then let's see whether we can see you. So Shen, you exit your sharing. I see just a blank screen with your mouse moving. Don't say anything.
I'm trying to figure out what it is exactly that I clicked. I'm trying to get out of it.
Okay,
But
get
it's
out
not
of
letting
it.
me.
It's if you look at the very top, there's something like a stop sharing. If you move mouse to the top,
Okay.
yeah, there you go.
Sorry about
Yeah.
that.
No problem. Jinchen, can you share your screen?
Am I sharing now?
No, not yet. Just go to press share, and the very bottom is a share button, and then you go to choose your screen to share.
Okay.
I clicked web browser, but I think you're supposed to click share content, or is it share my meeting window? Maybe.
Just share the screen. Share. I think it's very top. It's like a screen. If I do that, yeah, it's called yeah, there you go. Okay, Pinchen. Okay, to say that. Okay, so let me see what did you do with the path? So you use the Chinese system here. Okay.
Yeah.
Program files MongoDB server _4.0 and the bin. Okay, so now let's just stay there. Okay, let's go to the search button, type a command.
Okay, so do you mean this?
Yeah, this one, the command button. Yeah. Okay.
Yeah.
And then type Mongo. Let's see what you get.
That's it. Mongo.
Yeah. So
Okay.
this is not recognized. Okay, so now
Yeah.
let's do this. You could open up your Windows Explorer. Windows Explorer, yeah. Okay, and then so other people really cannot read this. So
Yeah.
Windows Explorer, not the Internet Explorer. Just say the button. You say the button that's just like a file like a photo. Click on the photo icon.
Which one?
The taskbar. You see the taskbar here in the very bottom of your screen. So besides Chrome, there's like a
Oh, this one?
yeah. Click on that. Okay. And you go to well, let me see. Move down a little bit. Okay, and then go to this computer. Click on this computer. Yeah, and then you go to C. Double click on C drive. Okay, and then go to program files.
Files.
Yeah, and then do you see MongoDB there?
Yeah.
Okay, double click on that. Okay, and then you see server. Yeah. So you actually is 4.4, not 4.2. You see that?
Okay.
Okay, so double click on that. And then there's a bin directory. Okay. Okay, click on that. And then there's a program called Mongo. Do you see that? So that is a program you can open. So what I would do is, no, not here. So you're going to go to, so move this Windows Explorer to let's do this. Okay, go back to your command. Go back to your command. Okay, type cd. Okay, and then space.
Yeah.
Space. Yeah. And then type double quotes.
Double quotes.
Yeah. Okay, Xiang, double quotes, not a backslash. Xiang, you should follow the same process, okay?
I am.
Double cross.
Double quotes, yeah, quotation.
Oh.
Double quotes, just one, okay? And then C, colon, backslash, and then program files, and then double quotes. No space. Yeah, enter. Okay. Now you type cd again, and then MongoDB. Okay, and then enter. Okay, and then type dir. Enter. Okay, so now you see that you have a folder called server. So cd, and then server. Okay, enter. Okay, so now type dir again. Okay, you have 4.4, right? So cd 4.4. Enter. Okay, now type dir again. So you have a bin directory, data directory. So just type cd bin, cd space bin. Enter. Okay, so now you're ready to type Mongo. There you go. That's it.
Okay, so this is successful?
So they're successful, yeah. So what happened is in the path, okay, just go back to your path. You change it to 4.2 to 4.4. The path variable, yeah, that's one. So you say that was not correct. So you have program files, MongoDB server, yeah, that's it. So then press OK. Okay, and then press OK again. And then press OK. So after class, you need to restart your computer, and then you will have no problem. Okay.
Okay.
Okay, Shane, are you working? Is working for you now? So
yes, I did it. So I'll have to do the same thing. I'll have to restart after class as well.
Yeah. That's right. So anybody else has a problem? Does anybody else has a problem? So even now, if there's no problem, this is what I'm going to do. We don't have a lot of time. My God. So now I'm going to skip this PowerPoint about installation stuff. Okay, so that will save us time. And then I'm going to share my screen with you. Let me decide which screen I will share with you. So the comment, I think it will be in here. If I switch to a different screen, it will look bigger. Okay, let's do this. Okay, so I'm going to share this screen with you. Second screen. Share. Okay, and then let me do this. I'm going to follow the PowerPoint of some of that, but then we will mainly put our hands on. So this is Shane's file. So I'm going to close that. Okay, so let's see MongoDB. If I do slideshow here, it will be in this screen. Okay, so let me see how I change this back. I don't want to do that because I need to use this screen to do demonstrations. And then we also save this, close this, Oracle developer. So that would be 6:41. Today is November 18th. Okay, let's save that script, close. Okay, so here is the command. So everybody knows how to get a command, right? So basically just go to source and type cmd right here. Okay, so I'm going to switch to the screen here. Okay, so you get that. Okay, so basically, so the second part is like give you like access to the path, the file path, and that is how you don't have to go to the type of cd, a bunch of statements to get the directory to open the MongoDB files. So if you already have that file file path linked, then you just simply type Mongo. Okay, so first thing you want to do is you want to check your MongoDB version. Okay, Mongo, and then type -- and a version. So that will give you which version. So in my case, I'm using 4.2, but you guys is 4.4. I realized that. So you download it from some other places, I guess, or maybe my installation was like the beginning of the year, so this might be different. Okay, so this gives me the version number. Okay, and if I just simply type Mongo, then I will get it to the command. Okay, get it to connect to Oracle, connect to Mongo, and then so it's kind of a strange here. You may ask, how do I, why don't I need to use ID use ID in the password and then say database like a server name or all that. So as a matter of fact, you have database installed on your local computer. So at this by default, you do not have any security settings. Okay, for example, any user access to your computer can just type MongoDB and get access to your database. Okay, so that's why. But if you want to go to set up those security things, then it's beyond this class. However, I think the book has a separate chapter on that. And also I have separate writing. I can post that, but that's not for Windows. But the same idea, okay? You just need to follow that to set up your security settings so that only certain users can access. Okay, so if you want to access certain user with user ID password, then you basically just say u -u and then you put user ID here. Okay, so let's say Scott. Okay, and then say password key and then you type a password. Okay, and then if you have some kind of like a host, okay, you type a host, you say which computer you're trying to connect. So you do have a command to access a remote database. So originally I thought I could use my equals to give you access, but then just I thought about that. I have not carefully evaluated security hosts for MongoDB, so I'm afraid that it may be problematic. So I decided that you just run your own MongoDB servers. Okay, so we can achieve the same purpose by doing that without accessing remote database server. So anyway, so we'll go. So let me go to connect to Mongo. So here, this Mongo actually is more. It's like an interactive JavaScript interpreter. So you can actually type JavaScript here. So let me just give you a few examples here. Okay, suppose I want to create create a new variables here. Okay, so I would just say variable, say my name. So you type my name, put that inside double quotes. So it's John. Okay, and then semicolon. So that basically give you a new variable called my name. So how do you know that? So if you type my name again, my name, then that will give you the whatever value inside the variable. You see that? So let's say if I want to do some kind of a manipulation. So let's say I want to have like let's create another variable, say age. Okay, so age is 29. Okay. Now let's try to use these two variables. So my name and then my age. Okay, let's try to combine them. So I will say my name. Okay, and the plus I put it like is. Okay, space. Okay, and then plus my age. You see that you are using variable to do calculations here. So we are basically combining text. Okay, combining my name and then put words is and then this, and then let's say years old. Okay, let's put double quotes, years old. Okay, so now let's see the result here. Okay, so give you some errors here. So here it says age is not defined. Age, my age is not defined. See that here? So I declare age, but not my age. Okay, so anyway, so if you replace the age, then this will give you like a sentence, say, John Doe is 29 years old. Okay, so let's just create another variable, say there's age, and then say plus 5. Okay, so that'll give you 34. So you can use this to experiment in JavaScript. Okay, so now let's try to get a date. Okay, so let's say if I want to get a current date, so I will say current say date. Okay, say date. That's the name of the variable equals to new date. This is date. Okay, make sure it's case sensitive. Semicolon. So this without any parameters inside the date constructor, this will give you the current date. So if you say type say date, that would you say that is old date. You say that. 2020, November 19th, so time is 01:53, what is this, 07797Z. So that's a Greenwich time. Okay, excuse me. That's a Greenwich time for the current time, okay? So if you want to create a new, like another date using using the same constructor, but using specific year or whatever, so let's just say B date, okay? B date is equal to, let's new date. Okay, so let's say year number 2001 and the month number and then date value 12. So let's just use 3, okay, December 12th. So that will give you a new date, B date. Okay, let's say B date. So that would be converted into like a MongoDB date. Okay, and you can also use this eState function to create something. So let's just say variable t equals to is o date. Okay, and then you put that inside the double quotes. So let's just say 2002 December 11th, something like that. Okay, so that will give you like a date without a time, right? So that will give you t, and so if you say type t, then they'll give you what is out of the variable. Okay. So anyway, this is this is actually very good good environment for you to practice JavaScript coding. Okay. But that's beyond what this class is going to be about. So I'm going to skip the rest. So let's go to mainly about a database. Okay, so I'm trying to open this PowerPoint and then get into the place that bypass installations. Okay, by the way, when you do installation, I ask you to use to get iatom and also commander. And that is just for you to have like a one environment. You can type comments and also just just say just like editor, text editor. Just say the type of comments and also to run the comments in the one environment. But I think somebody told me that the installation was not successful. Since we are running out of time, we cannot demonstrate that. So I'm going to just use this comment. So those things are just extra, okay, just for your convenience. So so I'm going to go to the place. Say let's see. Suppose I need to. So at this point, when you log in, at this point, okay, so we already log into MongoDB, and let's say you want to say what database do you have, okay? So let's say show DBs, okay? So in my point, in my case, I have like 5 databases, okay? So you should have something admin database, right? Or maybe local, but not MyDB, not reporting. You get that? And how do you create a new database? It's actually very, very, very easy. So suppose I want to create a new database called MyDB. The only thing you need to do is just say switch MyDB. Use MyDB. Okay, use MyDB. Okay, so now that's a switch to MyDB. So it's not a switch, it's just use. Okay, use DB. So if you do that, this database will be automatically created for you. So when you use that, and then if it does not have it, it will actually create it for you. So you see how easy it is, right? Okay, and then if you want to say what tables do you have inside that table, inside the one, you can just show collections. Okay, so in my case, I have like a student collection only, but you don't have a collection, right? And we will say that you can just when you create a new documents, and you're going to have a new collections to be. Let's just create one, okay? So what we do is just say DB, okay, and then that create or let's say you can just save, or you can just do let me just do what insert. So let's just create a. Suppose I create a new collection called test, okay? So test, okay, the new collection, and then so you can use save or insert. So let's just insert, okay? So insert parentheses, okay? Then inside you're going to put a complete document. Let's just create very simple document inside, okay? So curly brackets, okay? So that's surrounded document, and then inside you are going to have a bunch of key value pairs. Okay, so let's just create something simple. Let's say the name value, name column, name field has a value equals to say John Doe. Okay, double quotes, and then comma. Okay, and then say age, colon, and then let's say this is 29. Okay, so that create a simple document, and just imagine how how magical is that when you. So this just means that you're quite. Let me try to move over my mouse here. So you're trying to create this document inside a collection called a test. Does it make sense? And then this collection does not even exist. You see that? Because when you show collections, I don't have that, right? But if you enter that, if you just say semicolon, enter, and then you set write result. So that means data has been saved. So now if you do show collections again, the collection is there. The test collection is just created for you. You see that? Okay. And then how do you find the result? How do you find that the data is just inserted? And this is what you would do. So just say dp .test, that is collection, that's the name of table, and then say find. Okay, so if I don't specify any criteria, then that will give me all the documents. So in this case, it will actually automatically create the object ID. Do you see that? Okay, remember there's 12 bytes, and then you have like a value name. So automatically put double quotes on it, but I told you that that's not really necessary. And then there's the value for the name and the age. There's a number. The number you don't put double quotes around it, right? So this, this shows that by just simply insert a new document, if the collection does not exist, the collection will be actually created for you. Okay, and along with the object ID for that document, which is great. Okay. So let me try to go through a couple of comments quickly on how to, for example, create how to create data. Let's just create a new user. So suppose you want to create a new user, then the command I don't know. I'm running. I'm a little bit rushed because I have only 15 minutes left. Oh, let's see. I'm going to switch. Going to skip how to create a user, how to drop a user, this stuff. Okay, so you can just do that those commands by following following the PPT file. Okay, so there are a couple of files. Basically, just each one shows the command, and then just follow the command. You will be able to do that. Okay. So how to create a new user, how to delete a user, how to change a password. So I'm going to skip that. Okay. So now let's. So we already learned how to show all database you have. Okay. And how to create a new database. If database does not exist, just simply say use, and then that basically just create. Just switch to the one that if database exists. If it does not exist, it will create a new one for you. Okay. And then you can show collections. After you find the collections, then you just say db.collection name.find, and then you will be able to find all the data in there. Okay, so that is pretty simple. And now let's move on to how do you. So for example, how do you remove all the collections? So suppose this test, I already have a collection and then a bunch of objects inside. How do I remove it? So you do db.test, okay, and then .remove, and then you put a parenthesis. However, in this case, when you use a remove, it requires that you have a criteria. But if you do not have a criteria, just simply put this criteria, empty criteria. Okay, curly brackets, empty criteria. So that will remove all the objects inside. Does it make sense? So I have no way to comment here, but I just, just remember this. So everything is inside of my PowerPoint. Okay, so let me just demonstrate that. So here, the object will be removed. That document will be removed. Okay. Now, how do you delete the collection? So to do that, you just say db. Okay, and then .test .drop. So that the table, the collection will be deleted. Okay. Then how do you drop a database? So in that case, you just simply say db. So since we are currently using MyDB, right? So if you say MyDB, and if you say db.drop database, then the entire database will be dropped. Okay, so is there any danger for doing that? I have a student table in there. So let me just stop that. Okay, not doing that. Okay, so I might have some data inside of my students collection. Okay. So that's that. So we know how now we know how to create database, create collection, insert new documents, and then also do the opposite, right? Remove and also remove collections and remove databases. Okay. And let's say how do you can also change collection name. So let me show collections here. Show collections. Okay. So we have collection called student. If you want to rename that, you say db. But so what is called my db, right? My db. That's name of collection. Okay, and then just do rename. Okay, rename. Oh, okay. Actually, db you have to make that name db that collection db that students. So currently have student, and then say rename. Okay, and then rename collection. And then you just give a new name. Okay, suppose I want to rename that as students. Okay. Okay. So you reference to the collection, db.collection, and then say rename collection, and then that will give you so whatever the new name will be used. Okay. So it's okay. So now you can show collections again. There we go. So the name has been changed. And can you change the database name? Yes, you can, but it's a little bit more complicated. You have to write a couple of comments. So basically, you need copy the database to the new one with the new name, and then you drop the current database. Okay, so that basically just combination of a drop and a copy database db.copy database. So this is what you do. So db.copy database. So it's not very essential because you're not likely you're going to change database. Okay, so for example, you want to change to from MyDB to another name, for example, to UDB, double quotes, UDB. Okay, something like that. Then that's how you can change that. You copy the database MyDB to a new one, and then you can drop my database. Okay, so I'm not going to do that anyway. Okay, and I'm running a very, so this is, so we, I told you that this is the first time I will cover that. I don't know how fast this can go, but let's try to move on. So we learn how to handle dates, right? How to create the new data values. So I'm going to skip that. So let's try to insert a couple of student documents and with some, also with like a data values. Okay. So remember we have like a B date, C date, right? So we can use that. So let's just try to insert a student with a birth date. Okay. So into the students table, into the students collection. So we do this db that insert students, the name of collection, and then that insert. Okay. So parentheses first. Okay, so just in case you forget, so there you're going to have curly brackets. So you're going to have one collection. Okay, can you insert multiples? Yes, you can. Then in that case, you say insert many instead of insert many. Then you can put like a collection, just like a list of documents. So you put a square bracket, and then inside square bracket, you can put multiple documents. Okay, so here we do one document. So let's say student ID is 5555555. Okay, and then comma, that's student ID, and then student name. Let's just say is Laura. Okay, comma. Okay, and now what about the student birth date? So B date. So it's actually case sensitive. So I'm going to just make sure that is the same kind of value I used. So B date. So in this B date, which date I should use? So remember, I already have a date I created it before. I can use that, or I can just simply use new date. Okay, and then that basically just give today's date as birth date, which may not make sense for this student, right? But anyway, so we just practice that. Okay, or you can just use the one we just created, the variable which is created. So we can just refer to that. So let me see, I can get to that. I think we can. So remember here we have a B date, we have a C date, and also we have T. All of them are dates. So let's just use one of them. So let's just say this is C date. Okay, C date. So remember the C date was a variable, right? Okay. There we go. So this student has 3 fields into it. So enter. So write successful. Now let's do let's do I will skip that. So that's how you can just create a new document. So I'm going to move on. I'm going to move on to next one. Okay, so if you want to use sort of multiple ones, I told you that this is what we do. So I just say DB the students, and then I say insert many. So make sure it's case sensitive. Okay, so parentheses, okay. And then since we're in sort of many, so you're going to have a collection, right? You're going to have a list, array. So square bracket and square bracket. All right. And then you're going to have multiple documents. So for each document, it starts with curly brackets, comma, and then curly brackets, second one, and then curly brackets, comma, curly bracket. So suppose that you sort of 3 documents, then that's what you do. Okay. So for each document, you can just do say SID. So let's say 666. Okay, and then S name. So colon. So let's just say this is Bill. Okay, and then comma, and then let's just say at the mid date. Okay, and just say that's T. Okay, remember T was a variable, was data type, data variable we've created before. So you can use those variables inside those values as values for that. So then you finish the second document and the third document similarly, and then press enter, then these multiple documents can be inserted at one time. Does it make sense? So I'm going to skip that, move on. So a lot of simple stuff, but that does take a time to go over. Okay, so now let's say how can we find the records? Okay, so I just so we're going to learn how to query database next week, the week after you come back. Okay, so today I'm going to just do some basic ones. So for example, if I want to find one record, so just say you will do DB and then say students, the name of collection, and then the find. So if you do find, then find all records, right? So if you just find one, that will find the top one, the first record. The first record, okay? Find one. So the first one I created it before, so that's John Doe. So in your case, it's probably there's only you probably have only one in the list. Okay. And how do you search for example, particular record, particular document? And in that case, you have to use criteria. So the way to do that is I'm going to just introduce simple criteria here. So let's just say I want to find, okay? And then parentheses, and inside that you're going to use criteria. The criteria will be inside, will be like a document too. So you're going to have curly brackets around that. And the first one will be, you can have field. Okay, let's just say S name. Okay, and then colon. Now the second one, the value is say I want to search for Lisa. Okay, so that basically is just saying that you'll find a student document whose student name is Lisa. Okay. Okay, so find that the student found. So if Lisa, if you don't have Lisa, then of course this will not return any result to you. Okay, and if you also want to find just say Lisa's particular field, like ID field or student ID field or whatever, then you're going to do something like this: DB students find one. Okay, you have to find one because in general finder can find many, right? But you can find one, and I will show you how do you handle that if you find many and then you're trying to get one column also. So let's just say find one and then go put also criteria inside. Okay, and then say that, and then underscore ID. So remember the ID field only, right? So now let's go back to the inside, trying to do the criteria. So as name is equal to Lisa again. So you're trying to find documents whose as name student name is Lisa, and then just find one. Okay. So if you have multiple, it will return only the first one. Okay. Okay. So this object ID, you get that? Make sense? And I told you that you can also get a stamp. This ID has like a timestamp, right? So let's try to get a timestamp. So I'm going to just use your arrow key, up arrow key, to retrieve the previous comment. Okay, just use up arrow key to retrieve your previous comment instead of typing or copying. Okay, so then here you can just say get time stamp. Parentheses, call it parentheses, yeah. So that will show you what is timestamp for this particular object ID. So what time this object was created. Okay, so now you say, oh, something wrong. It's not a function, really. I misspelled something. Get timestamp. Let me see. Did I misspell anything? Okay. So DB students find one, okay, then underscore ID, and then get a time stamp. Oh, this capital, this not a capital S, just small s. Okay, sorry. Time stamp. See that? And then this will give you the time that the object, the timestamp for this document was created. Make sense? So I have few more slides. I think I have probably used extra time. Hopefully I'll give you the time back. Okay. And now let's try to do what? Trying to find the last one, the record I created last one. So to do that, I am going to, let's do the same thing. Okay, db.students. Find. Okay, so that will give you find many records, right? So I'm going to sort the records first. So how do we sort? So I'm going to sort, okay, and then inside I'm going to put a sort criteria. So after I sort, I will just say limit how many. So I will say limit 2 or limit 1. So if I just want to get the last 2 records, then limit 2. Okay, so before I can get the last 2, the limited 2, the first 2, I will have to sort this using the criteria. Again, the criteria is like a document, and I'm going to sort it based on ID. Okay, ID field, colon, and then we can use either 1 or -1. So 1 will be A seminodal, and -1 will be D seminodal. So if you want to get the last one, I will use -1. Okay, so this will give you the last 2 records you created. Does it make sense? Okay. So this is Laura. Those are the 2 objects I just created in today's class, right? Okay, and let's move on, and then we're pretty close. We just have 1 or 2 more slides. Okay, bear with me. So probably need to use extra 5 minutes. And then next one, let's just say I want to get object ID for all objects. So this one give you just say if you want to get a timestamp or get like a particular field like ID field, you can only just use a final one, right? Final one here. So what if I want to show all the column values? I want to get all the column values. So in SQL, that's a pretty easy thing. But here you have to use some kind of loop to do it. So this is how you do it. Okay, so db.students. Okay, and then say .find. Okay, so this will give you what does this do? This will give you all the documents, right? And then I need to use like a loop for each. So students in three 643 learn how to use for each. Okay, so we can use for each, and then put parentheses around it. Okay, and then this will give you some kind of control to go over every document that you find. Okay, and then for each document, this is what I'm going to do. I'm just simply just print ID. So I will just create a function inside for each. I'll say function, and then say doc. The name that the parameter is doc. Okay, the doc, and then curly brackets. So I'm going to have function body. The function body is just simply just one comment. You can have multiple comments, but I have just one comment here, which is a print JSON. Print JSON. Okay, and then so then you basically inside the function inside that you can just any kind of JSON you want to print. So what I want to print is just simply doc dot underscore ID. So that is just for each document I print ID. Okay, and there we go. So this will give you all the IDs. All the IDs for all documents. Okay, so you have the same idea. If I want to get a timestamp for all these documents, I will just use up arrow here, and then so to print student not ID, but also we want to apply the function get timestamp for each ID. So that, but just simply insert after your ID, then say get timestamp, and you will be able to get a timestamp for each object ID. So you see that those documents, the time that was created. So 5 of them was like November 14th, and one of them is 19th, which is today. Okay. So let me say whether we are getting close to that. Yeah, this was pretty long. Okay, one more slide. So what if you want to print multiple rows? So in SQL, that's pretty easy thing, right? You can select like e-name, comma, job, you get 2 columns, right? Here, you have to use this similar mechanism, use like a while loop, like a for loop thing. Okay, so we do dd dot students dot find. So this will find all the students, right? And then we do for each again. For each. Okay, and then just put that inside the parentheses. Okay, inside the parentheses. So let's do the step by step. Okay, then inside that, I'm going to create a function, and the function. Okay, then the parameter is doc, D-O-C. Okay, and then curly brackets. That will include the function body. So the function body in this case is very simple. I'm going to just create a print JSON also, but print create like a list array. Okay, print a list. So I'm going to say print JSON. Okay, and then parentheses. Okay, and then inside I'm going to put like a JSON document. So what I need is in this case just simple a list array. So the array will have two columns. Let's just try to get ID and also student name. Okay, so doc dot underscore ID, comma, and then doc dot s name. So those are the 2 columns. Okay, and I think that's it. So basically, the print JSON in this case, you print it like a list, print it like a array. Array consists of 2 fields, ID fields and student name field. Okay, so let's try that. There we go. So here we see this object ID and also this student name here. Okay, I think that's the last slide. So there are a couple of slides I skipped, like creating users. What else I skipped? Let me check. Okay, so I covered that. So sorry that we overused a few minutes. I think it's probably because I was helping Pinchen and Xian to fix their installation problem. Okay, so otherwise we should have enough time. So we learned how to copy database, drop database, all that. So not much. You pretty much covered everything. Okay, covered everything. So now let me stop here to see whether anybody have problems, questions. So to get out of that, just say quit, and then parentheses, and then you exit. Okay. So now you exit out of it, and then this is coming back to your command prompt. So I am going to stop recording for now, and let me see whether anybody